The broadcast is now starting. All attendees are in listen-only mode.
Good day and welcome to today's webinar titled Reducing Rework and Improving Productivity with Upfront Design for Manufacturing Validation. I am Prashant Shalke, Marketing Manager at Geometric Limited. I am the moderator and host for today's webinar. I would like to thank everyone for joining the webinar. Before I hand it over to the speaker, let me share the logistic of today's event. Webinar is approximately 45 minutes. We have kept all attendees in listen-only mode to avoid any background noise. We do of course welcome your questions during the presentation. In order to submit your question, simply type in using chat window on your GoToWebinar console. We'll attempt to answer as many questions as possible during the end of the presentation. Please note we are recording the session, so we'll send a follow-up email with link to recording later this week. So without further delay, let's begin the presentation. I'll hand it over to presenter Rahul Rajadhyaksh. Rahul.
Thanks, Prashant. Hello, everyone. As Prashant mentioned, today's webinar is titled Reduce Rework and Improve Productivity with Upfront Design for Manufacturing Validation. I am Rahul, your presenter for this evening. I'll just reiterate what Prashant said. As shown on the screen, please use this icon to put the GoToWebinar window in the full screen mode. You can use the raise hand icon for questions or type them in the questions window. We'll be answering all questions collectively at the end of the webinar. We'll start this webinar with a brief overview of Geometric. Geometric is a leading provider of engineering solutions and services to the world's renowned OEMs. With a strength of more than 4,300 people and global presence, Geometric serves clients in all corners of the globe. We have strong relationships, not only with industrial customers, but also with the world's leading CAD and PLM vendors. Geometric has a strong set of homegrown products and patented technologies. Here is the agenda for today's webinar. We begin by setting the context, looking at the typical industry challenges in new product development. Then, we'll look at the various influencing factors for these challenges and issues. Look around and we see designs getting more and more complex. Is there a systematic approach which one can use to address this design complexity? We'll look at that. Next, we focus on what Geometric offers in this context. For the larger part of this webinar, we will focus on DFM Pro for Cryoparametric and look at how it simplifies your job of creating designs which are easy for manufacturing. We close this session by looking at the benefits you can gain by adopting this solution. Let's begin by looking at the results of a survey published a few years back. The top 3 issues observed by global organizations in new product development are related to being late to market, thus missing demand, having pricing issues, and issues related to product quality. Thus, we can see that the most important issues still relate to schedule, cost, and quality. Let's go one level deeper and look at the possible factors which may help influence the schedule, cost, and quality. In this slide, I have listed some of the factors which come to mind. Which factors impact the schedule and release to market? Rework? Yes, it could be rework in design to address downstream manufacturing issues. It could also be rework in manufacturing due to scrap. How about higher manufacturing time? This could be another factor. If the manufacturing time taken for each product is high, it impacts volumes. Can design influence manufacturing time? Definitely. Choice of a thick wall in case of plastic parts, choice of a slower manufacturing process. For example, sharp corners in a machine part could lead to choice of EDM as the manufacturing process, thus impacting not only time but also cost. Choice of exotic materials could lead to higher material cost impacting pricing. Tight tolerances lead to additional secondary processes, thus increasing manufacturing time and cost. They also put a higher demand on machine process capability, possibly impacting product quality. Choice of non-standard features also impacts the manufacturing time and cost. This could be due to the need for special tools and processes for manufacture. In addition to the factors listed here, there could be various other factors which need to be looked at during the design stage. And that's not all. On top of all this, designs are getting more complex day by day. Day by day, your designs are pushing the limits, allowing us to do things which have never been done before. But is product functionality the only element a design engineer has to pay attention to? Hey, my design works. Is that sufficient to say when you have to stay competitive in the marketplace? No. A design engineer has to pay attention to various factors like quality, reliability, manufacturability, ease of assembly, serviceability, etc. Is the wall thickness of my part uniform? Will these materials corrode when in contact? If I provide this fillet radius, can it be achieved through a standard casting process? A designer has to answer all of these questions. And what if these points are not attended to early in the design stage? There will be rework, impact on quality, higher cost, and whatnot, finally leading to failure of the product in the market. How can you as a design engineer address these challenges in a systematic manner? By applying Design for Excellence or DFX in the design process in your organization. Design for Excellence consists of methods, guidelines, standards, and checks for creating better products focused on providing benefits in multiple stages of the product life cycle. Geometric provides solutions for organizations to practice and implement Design for Excellence in a systematic manner. Geometric DFX is an extensible standalone platform and framework which facilitates the DFX initiatives in your organization. It consists of various components such as inbuilt best practices, a rule engine, packaged technologies such as feature recognition, thickness analysis, among others. Also, report generation facilities. The DFX rules or best practices are derived from various sources such as in-house manufacturing experts, customers, design handbooks, and various standards. For ease of use of this solution for design engineers, we have packaged the solution focusing on manufacturing and assembly and created an add-on on popular CAD systems such as PTC Creo Parametric, Siemens NX, and SolidWorks from Dassault Systems. DFM Pro brings the extensible and customizable geometric DFX framework to your CAD system. Today's demonstration will explore DFM Pro for Creo Parametric in depth. Watch out for forthcoming web sessions covering other CAD platforms. What does an easy-to-use design for manufacturing validation solution for design engineers need to have? A CAD PLM integration, a strong, extensible, and configurable knowledge database, and a facility to collaborate with effective reporting. In the following demonstration, we will see how DFM Pro provides this and much more. Let's shift to a live demo. I have Creo Parametric open on my screen now. As we can see here, DFM Pro is tightly integrated within the CAD environment. In this case, Creo Parametric. DFM Pro will provide recommendations to ensure that your designs are created as per well accepted global and organizational best practices. Let's consider a regular use case in the design of a plastic part which has to be injection molded. We have reached a logical state of the design. As a design engineer, I want to validate my design to ensure that it is going to be easy to manufacture. DFM Pro can be launched at the click of a button. I select the relevant manufacturing process, in this case injection molding, and start the validation. For injection molded components, DFM Pro will identify the pulling direction along which the mold separates. If required, we can flip or change this direction. Additionally, DFM Pro will also compute the nominal wall thickness of the part, which can also be overridden by the user. In addition to the manufacturing process, the second input for DFM Pro is the rule file, which contains the list of checks to be used for evaluating the manufacturability of this model. DFM Pro identifies all the manufacturing features on this model. For plastic parts, features like nominal wall, draft angles, ribs, bosses, and undercuts play an important role in determining manufacturability. Based on the identified features and their parameters, rules specified in the rule file are applied, and any recommendations are shown to the user in the results section. What's important to me as a design engineer is quick identification of those areas of the design which can negatively impact manufacturing quality, time, and cost. DFM Pro helps you do exactly that. As you can see here, it processes each individual rule which is selected in the rule file. Manually validating this design would take hours, whereas DFM Pro can do that for you in a couple of minutes. Now on the right hand side of the screen, we will see the results in the results section. When I click on any rule right here, in the message window or the dashboard area at the bottom of the screen, we can see the corresponding summary of the rule. This provides the required explanation so that the appropriate downstream manufacturing knowledge is made available at the design time, right when it matters. For example, here this instance tells me that the rib is too thick. the nominal wall thickness to rib thickness ratio is too high. It not only shows me the associated rib in the graphics area, but it also shows me the current value in the dashboard and the recommended value. This helps me improve my design such that it will be easy to manufacture without defects. Thick ribs can lead to sink marks, hence I need to reduce this thickness. I can get more information about the reason behind this recommendation by launching the help file. In addition to a compiled help format, the help file is also available as an HTML document so that organizations can host it on their intranets and edit the help file to include their own internal best practices and tribal knowledge. The help file provides a detailed explanation of the rule, the recommendations with an appropriate image. We can see that there are too many failures for the minimum draft angle rule, and I know the reason for this. I have not applied any drafts as per my nominal design practice. I will apply draft when I am done with the basic design and before I round the sharp corners. This check in DFM Pro helps me ensure that I don't miss out on any surface for the required draft. Thus, DFM Pro watches my back while I concentrate on the design functionality. I do see instances during the daily design activities where DFM Pro helps address any oversight on my part. Now look here. This is a modeling error and it has led to an undercut. Definitely this is not intentional. Undercuts would need side actions, lifters, moving cores, thus leading to additional time and cost. The undercut detection rule identifies such reasons in the model. I can then decide if it can be eliminated by slight modification of the design or it needs to be handled in tooling. For this part, I need to figure out how to correct this modeling error. Can I just delete these faces or modify the related feature? That's part of the CAD design process which I do every day. On the other hand, in this case, I have a feature here which is an undercut, but this is a design requirement. I know it is going to require additional tooling, but I feel it cannot be avoided, so I am going to go ahead and ignore it. I will capture an image and add my comments. These details will be communicated to manufacturing when they look at this part, and my DFM report. We'll come back to the cool reporting aspect in a short while. Thus, we can see DFM Pro helps me detect many of the downstream issues as I am designing my part. DFM Pro also helps detect thick and thin regions in plastic parts. The uniform wall thickness rule checks areas which can cause problems during filling and also lead to quality issues. Here we have a region which is very thin. In the message window, we can see that it's just 0.138 mm, far less than the recommended value. On looking closely, we can see that a depression on the other side has led to this thin region. I will collect all the information required, know more about the rule, and then I can correct the design. Let me add a round here to increase the thickness. Now that I have modified my design, I can rerun DFM Pro and check what is the impact. As you can see, the background turns yellow, telling me that the results are not in sync with the design. As a design engineer, I am interested in quickly verifying the design, understanding the reported recommendations, and improving the design iteratively till it is as per the recommended guidelines of the organization and fulfills the design requirements. DFM Pro helps make this iteration happen on my desktop before it can be sent for review or for manufacturing. Thus, a lot of review hours and rework can be avoided. In this case, DFM Pro will relook at the design, identify the modified region, recheck that region, and present the results to me as before. We will see that the count of the wall thickness recommendations will decrease because of the design improvement. And yes, the count has decreased from 13 to 10. That region has now passed. It's not necessary to run DFM Pro after every design change. You can keep on doing your design modifications, look at the results, and after you have done a few of them, you can iterate over the design to ensure that you can move to the next step. Another aspect you may be wondering about is the rule file I mentioned earlier. Where do these rules come from? How do I configure them? The process is very simple. As a design engineer, typically you will not need to look into those details. But let me just show you what's going on behind the scenes. I clicked the edit button to launch a small utility called the DFM Pro Rule Manager. Typically, when organizations deploy DFM Pro, it can be used out of the box with inbuilt best practices and configurations, or we can create new rule files, select the appropriate rules based on the manufacturing processes in the organization, configure the ones which are required for modification, leave the other ones, and save the complete set as a rule file. This rule file can be reused again and again. Rule file creation is typically a one-time or infrequent activity. During day-to-day design, I don't even need to click the edit button or look at the rule file. Using this mechanism, DFM Pro helps organizations capture not only the organizational best practices, but also supplier-specific ones, and make this downstream knowledge available when it really matters. That's during the design stage. This helps me save a lot of rework using the power of the knowledge available at my fingertips. As part of the design review process, DFM Pro also helps me quickly generate reports which I can submit for review. DFM Pro supports three kinds of reports. First, a 3D report in the eDrawings format, an XML report which can be viewed in the web browser, and an Excel-based report which can be used for tracking purposes. Let's look at these reports individually. The XML report provides a summary of the complete manufacturability analysis, starting with the environment and the settings. It presents a summary of the results and information of how many instances were validated, how many passed, how many failed. This is repeated for every rule. For every rule parameter, a table is presented to the user which shows the actual value of that parameter in the CAD model, the recommended value specified in the rule file, and the number of instances which failed. We can see that this information is common for all rules. The ignored warning is also captured separately. On the other hand, the 3D report is more interactive in nature. It contains complete information about the analysis along with the CAD model in compressed format. It can be viewed in the free viewer and is delinked from the CAD system. Hence, it can be shared with any user inside the organization or outside who may not have access to the CAD environment. Thus, it forms a very easy means of effective collaboration. Just like in the CAD environment, when we click on any instance, it is highlighted in the graphics area and the recommendation is shown in the description area at the bottom left corner of the screen. In addition to this, it also has annotation and markup facilities. This helps me record my comments in that same report. That's why it becomes a very effective and easy tool for collaboration. The Excel report is very useful for tracking purposes. Based on a customizable template, it provides a summary sheet with links to individual results for every rule. In the detailed rules page, we can see there are additional columns for tracking your action items to closure. Ignored items are also captured with the image and the additional comments. As a design engineer, I work with not only plastic parts but also machined sheet metal parts and assemblies. DFM Pro helps me during design of those parts as well. Let's look at a machine component. The same rule file can be retained for all processes. I'll select prismatic mill as my manufacturing process and execute DFM Pro. For machine components, features like holes, pockets and slots are identified. Since we use our patented feature recognition technology for identifying the features, the same results would be obtained based on the final geometry of the model, irrespective of the design steps. Even if the model is imported, say as a step file from a different CAD system, you would still see the same kind of results. In this part, you can see it's a mixture of imported geometry and certain design features. For machine parts, important considerations like angular holes, sharp internal corners, deep narrow slots, deep radius corners. All these checks are done in a couple of minutes. Let's go quickly through some instances. Here we can see that the hole exits on a non-planar surface, which can cause drilling problems. We have many examples of flat bottom holes. Here's an example of a pocket with sharp corners. Here are two intersecting holes, but the axis is offset. So this can cause drilling problems again. You will find that this dashboard area provides the reason for this rule and what can be the recommended action. Here's one instance of an inaccessible feature. This rule detects such narrow regions. Do we have a tool which will ensure that this area can be machined easily? Based on the configuration, DFM Pro can help you check very quickly whether your part is easily manufacturable or not. Let's look at a sheet metal example now. In today's webinar, we are just covering a broad overview of the capabilities of the software. We will have follow-up sessions where we will cover each of these rules in greater depth and also cover other CAD platforms. Again, the workflow remains the same. I use the same rule file, just change the manufacturing process and execute. In case of sheet metal, features like bends, flanges, cutouts, stamps are identified and the selected rules are applied on this model. The advantage of DFM Pro is that even if you have designed the sheet metal part using normal modeling features and not using the sheet metal features, still you will get the same kind of results. For sheet metal, issues related to feature spacing, such as in this case, we have two close countersinks, or features being very close to bends, like in this case. Less bend radius based on the material configuration. Again, an example of feature spacing, distance between cutouts, the whole distance to this cutout, cutout distance to bend. These are just few of the examples which DFM Pro can help you validate quickly as you create the design. And what about assemblies? You can also validate your assemblies using the same kind of process. I start DFM Pro, select the appropriate rule file. In this case, I select design for assembly because I want to check for the assembly process, and execute DFM Pro. Assembly checks in DFM Pro include hole alignment, fastener clearance, fastener accessibility, interference, among others. The hole alignment check helps detect axial and angular misalignment of holes in the assembly. Fastener assembly checks help ensure ease of assembly as well as disassembly. This not only prevents some of the assembly problems on the shop floor, but also avoids operational issues. Here is an example of an hole alignment issue. In the dashboard area, we can see the amount of axial misalignment, an example of an interference check, definitely this is not intended. Similarly, there are other checks related to fastener accessibility, fastener clearance, engagement length. Each of these have different benefits in terms of the assembly and disassembly on the shop floor or in service. We can get more information on all of these checks through the help file. Each rule has a very detailed information covering the explanation, configuration, and any recommendations. Thus, DFM Pro allows you to cover a vast breadth of processes and in each process a great depth of individual rules. This helps ensure that your designs can be quickly verified for manufacturability, assembly, and corrected right when you are designing them. This demo was just a glimpse of the various examples in which DFM Pro can be useful for you. We covered a broad overview of the software and how it can help you in the design process. For more detailed information on the capabilities and features of DFM Pro, you can also visit our website, write to us, and look out for detailed webinars on chosen topics. Let's move back to the presentation and look at the benefits you and your organization will get by adopting DFM Pro. DFM Pro can benefit you and your organization in many aspects. Productivity improves due to reduction in design iterations and DFM analysis time. Reduced number of defects result in improved quality, in addition to reducing time required for reviews. Standardized reports automatically generated by the tool help in easy and quick collaboration. Identification of design areas which can be difficult and expensive to manufacture ultimately benefits the product cost. DFM Pro facilitates capture and reuse of global best practices. It provides a framework to retain and disseminate the manufacturing knowledge in the organization. Statistics on the recurring design defects can help define training needs. Now it is time for your questions. You can click the raise hand icon for questions or type them in the questions window. Okay, we have a couple of questions. The first question is, what about webinars for other CAD platforms? Yes, as I mentioned during the presentation, we will have a series of webinars where we will cover the DFM Pro integrations with other CAD platforms, as also we will talk about our standalone platform, which is Geometric DFX. We'll also have other webinars where we will go in depth into the individual use cases and how the rules in DFM Pro benefit at the design stage. Okay, the next question is interesting. Does the additional checking process reduce the design engineer's productivity? That's definitely not true. If you look at the complete workflow, a design engineer's job is not complete till the product is out in the market, right? He will complete the design, then there will be reviews, it will get prototyped, manufactured. So in all these cases, there is chance for rework. So if there is rework, final productivity is going to go down. Similarly, if you are referring to handbooks off the shelf, existing books, then it takes time to go through each individual requirement. Go to the DFM handbook, open that particular page, look at the recommendations. What DFM Pro does is make the handbook live for you. So as you are designing, it will immediately compare your design against the recommended best practice, and not only the global best practice, but your organization's best practice. So for the organization, it ensures knowledge sharing, knowledge capture, and finally, a better product. We have one question here which says, how efficient is this software compared to CETOL? Okay, DFM Pro and CETOL are complementary software, right? Both of them perform two different tasks. CETOL focuses on tolerance analysis, and that's all, right? Whereas DFM Pro helps you check design for manufacturing, for individual parts, and for assemblies. If you take a machine part and if you want to know, okay, if I take it for milling, can I manufacture the part easily, or will there be a lot of setups, a lot of fixture creation? Will there be some rework? Will it lead to scrap? Such questions are answered by DFM Pro. Whereas a tolerance analysis software will help you define your stackup. So when you define an assembly, or when you're defining a stackup of dimensions, are they leading to a lot of variation? Are you within your tolerances? That's all what a tolerance analysis software will do. Whereas DFM Pro focuses on DFM validation, checking your designs for ease of manufacturing. So it could be processes like molding, machining, sheet metal fabrication. The next question is, when was DFM Pro initially released and what is its current version? DFM Pro was initially launched in 2007 on SolidWorks. We started with the machining process, and over a period of time we have not only covered the popular CAD systems but also expanded the scope of our support for various processes. Right now we support machining, sheet metal fabrication, plastics, castings. We are also adding a new module for additive manufacturing. In addition to that, many organizations also configure their rules based on the internal best practices. There may be some special processes which can be added to the tool as well. Currently DFM Pro is in its third generation, so the current version across platforms varies, but it's around 3.6 or 3.7 depending on which CAD platform you're on. Okay, I think I have partially answered the next question, which is, do you support DFM for 3D printing? In the current version which I have shown, we don't have a module for that yet, but we already have a version supported. You will find a video on YouTube on our standalone platform where we have rules and checks for design for 3D printing. And very soon we will be having it across other CAD platforms as well. So in case you are interested, do write in and we'll be happy to help you. The next question says it relies on rules to check injection molded part, machining part. How reliable are these rules? As I mentioned during my presentation, we do ensure that the rules are live. That is, they are not outdated rules. We work continuously with in-house manufacturing experts, external consultants who are experts in that particular process, standards which are published by various bodies. We try and keep pace with all these developments and we ensure that those rules are live. The reliability of the rules definitely depends on how relevant they are to today's scenario, and we keep on updating these rules, the values based on feedback from various sources, and most importantly our customers. And that's applicable across processes, whether it's molding, machining, sheet metal. There are various governing bodies which define standards, guidelines, best practices, and these have been accumulated and refined over the years. The next question is, can you list some big companies that have implemented DFM Pro? Unfortunately, I can't reveal names in this webinar, but definitely we would get in contact with you and we can have one-on-one discussion on your question. We'll be happy to understand your use case and how we can help you deploy DFM Pro. Okay, I think I'll take the last question. Where is the rule file stored? Is it a database? Okay, so to simplify things, what we have done is the rule file is in the XML format. So it's a human readable format. That means organizations have free and complete access to the information within that file. Okay, you can open it in Notepad, look at the information, you can post-process it using your own tools. That being said, it's not a database, so you can create different versions of rule files. You could have process-specific rule files, you could have product-specific rule files. So for example, if you say that for this particular product, these are the check items or these are the manufacturing assembly requirements. So all your products in that family can be validated using that framework. Similarly, you can create supplier-specific rule files where you define, when I ship this part or this assembly to this particular supplier, are there any possibilities of manufacturing violations? Can I correct them upfront? So you could define those standards, best practices, or constraints which are defined by your suppliers at your end and validate them during the design stage. I think the last question is, do you offer a trial version? We do offer trials and it depends on our engagement with you. So we have noted down your question, we'll get in touch with you. Do write in if you're interested for further discussions, looking at the demos of the software, and we will help you set up the software in your environment as per your best practices so that you can derive maximum benefits. Okay, I think we have run out of questions. So that's all from us today. Thank you for taking time to attend this webinar. Please do contact us in case you need additional information, and look out for more of such webinars in the future. We will have a repeat of this webinar on October 14th. So any of your colleagues who could not attend today can sign up for next week. If you want to have another look at this webinar, we will have an uploaded recorded session on the website. Bye for now and have a great day, everyone. Thanks again. Bye.